Hello everyone, I am Anitha Kripanidhi, Assistant Professor of Chemistry at Marri Reddy Institute of Technology and Management. In the last class, we have discussed about the classification of polymers. In continuation with that class, today we will discuss about polymerization from engineering chemistry. Now today we'll see about the topics polymers. In the polymers chapter, first one we'll see about polymerization. So what is meant by polymerization, and then what are the types of polymerization, and one more important topic we will discuss today, that is mechanism of free radical addition polymerization. Okay, so now here first we'll see before going to the topic, first one, what is meant by polymerization? Okay, so what is meant by polymerization? In the last class, we have discussed about what is meant by polymers, and then what are the different types of polymers we have discussed under classification. Now here today it is polymerization. In this polymerization, it is what is meant by polymerization means here it is monomer molecules. All the monomer molecules, that is what is meant by monomer. Monomer is nothing but it is the small units. Okay, so here if you observe here, all these are the small units which are called as monomers, and these monomers they combine and form a long chain, which is known as polymer of high molecular weight. Okay, so here it is in this picture you can understand these monomers they combine and form the polymer. This process or this chemical reaction is called as polymerization. Okay, now based on mode of polymerization, this polymerization is of two types. Based on mode of polymerization, these polymerizations are of two types. One is addition polymerization and the second one is condensation polymerization. Now we'll see what is meant by addition and condensation. So here it is addition polymerization. Now it is addition polymerization. You know already what is meant by polymerization, right? So what is meant by polymerization? Polymerization is nothing but it is a combination of monomers and that reaction. And next addition. Now here addition, what is meant by addition? In general, you know the meaning of addition. Addition means here in this polymerization, it is nothing but the adding of the monomers. Okay, so adding of the monomers takes place like for example, if you take this is one monomer and then this is another monomer. Okay, these two monomer means it is a small unit, right? So these two monomers, this is one and this is another. These two monomers they combine, they add, monomers gets add up. Okay, so here these two monomers they get add up, they get add up and form a chain, and this one also combines with one more monomer, and next it will be a chain will be increases. Like this adding of the monomers takes place, so a chain is increases. Okay, so here just adding of the monomers taking place, that's why by this the chain of the polymer it increases. That's why it is also called as chain growth polymerization also. Now here we are just telling that it is the monomers combined. What type of monomers or what are the conditions it should have for this addition polymerization? Okay, so addition polymerization means it takes place in the compounds containing multiple bonds. Multiple bonds means either double bond or the triple bond. Either double or compounds containing double or triple bonds or the multiple bonds, those compounds undergo the addition reaction. So this one here, if you see here, this is one monomer. Here bond is there. This double bond or the multiple bond, if you take this double bond, here one bond is sigma bond and the other bond is the pi bond, right? You know already it is in the multiple bond, one bond will be the sigma bond and the next one is the pi bond. It is sometimes it is not even a bond, but just we can call it as a electron cloud. Okay, electron cloud. So here it is a pi bond. This electron cloud or the pi bond is a weak bond. So that's why this bond breaks. this pi bond breaks and it can add up the another monomer. Okay, in this way the reaction takes place, this addition polymerization. So here in this addition polymerization, if you see this monomers, it is a monomer, here double bond is there, it is converted, it breaks, that pi electron it breaks and forms a new bond. If you observe this chain, here the new bond is there between the two monomers, like this, here new bond is there. These are the repeating units like this. It is a because it is a polymer, we will write a bond here. Okay, so now it is a polymer. It is called as addition polymerization. In this addition polymerization, there will be no byproducts. Next, here it is the, if you see here, just it is one more picture to understand. These two are the monomers. When all the atoms present in the monomers are retained in the polymer product. That means what is the meaning of the sentence is, here it is that this is one monomer, right? It is one monomer, here two carbon atoms are there, and it is another monomer, here also two carbon atoms are there. Now, if you see the polymer chain, all these four carbon atoms are retained in the chain. This number of carbon atoms are not decreasing. That means carbon atoms are not eliminating from the reaction, right? Just adding of monomers is taking place, right? So here just the adding of monomers is taking place, and after adding, that chain of the polymer increases, that length of the chain of the polymer increases. That's why molecular weight also increases, right? So here it is the addition polymerization. Next, come to the condensation polymerization. This is the second type of polymerization. What is meant by condensation polymerization? In this condensation polymerization, it involves polymer formation. Here it releases byproducts. Okay, so in the addition polymerization, only the monomers they add up and there will be no byproducts. Now here, when two monomers combine here, it leads to the formation of a polymer, but there will be the release of the byproducts takes place. Okay, so that means elimination of byproducts like water, ammonia, CO2, like the small molecules will be eliminated in the reaction. That is called as a condensation polymerization. It is also known as a step growth polymerization. Clear? Now, next we'll see the today's topic, the important topic, that is the, now we will discuss about the mechanism of free radical addition polymerization. Clear? So here it is the mechanism of free radical addition polymerization. What is meant by polymerization? You know already, you understood already this one. And next, what is meant by addition polymerization? What is the meaning of addition? Addition polymerization, that also we have discussed. Now, if you see here, it is the mechanism. Okay, so what is meant by, what is the meaning of mechanism? Mechanism means here, for example, when a chemical reaction takes place, what is the meaning of a chemical reaction? When we call, that is nothing but reactants converts into products, right? So when reactants converts into products, then we can say that that chemical reaction occurred. Okay, so for that, if a single step in that reaction converts into products, it is just a single step. But if we tell how those products are coming in a series of steps, okay, if we explain in a series of steps, like first step, second step, third step, fourth step, like that, if you explain in the series of steps, all those steps is called as mechanism. Okay, have you understood this one? What is the meaning of mechanism? So all these series of steps of a chemical reaction, that is called as a mechanism, right? And next here, one more word is there. What is that one? It is the free radical addition. Okay, now here our topic is what? Free radical addition polymerization. If the polymerization takes place, or if the addition reaction takes place in presence of a nucleophile, if the addition reaction takes place in the presence of a nucleophile, which is electron-rich species, in the presence of nucleophile, then it is called as nucleophilic addition. right? And next, if it takes place in the presence of electrophile, then it is called as electrophilic addition. Now, if the addition reaction takes place in presence of a free radical, okay, in presence of a free radical it takes place, then it is called as a free radical addition polymerization reaction. Okay, now have you understood this topic name? Have you understood the topic? This topic is called as the mechanism of free radical addition polymerization. Clear? Now here, when you see this, we will discuss for later what is meant by a free radical. Just if you see the picture here, free radical, in the presence of a free radical, this polymerization reaction is taking place like this. These are the monomers. All these monomers, they combine and form a chain like this. Okay, so it is a chain, it is a polymerization, free radical addition polymerization. Now we'll see what is meant by a free radical. Okay, so what is meant by mechanism, and then what is meant by addition, and then polymerization, all these points we have discussed now. Now what is meant by a free radical? How this polymerization takes place in the presence of a free radical? So what is meant by a free radical means these are formed from the homolytic fission. Free radicals are formed from the homolytic fission. Before that, for this formation of a free radical, in the chemical reaction, what happens when reactants converts into products? Suppose these are the reactants converts into products, right? So when reactants converts into products, then we can say this chemical reaction is taking place, or the chemical reaction occurred, right? So what is meant by a chemical reaction? Further to occur a chemical reaction, what should happen in those reactants means though bond cleavage, bond breaking takes place, or making of the bond takes place. Okay, so either breaking of the bond or making of the bond takes place. So here when bond breaks, that is called as bond fission or the bond cleavage. Okay, so when bond breaks like this, so when bond breaks, what happens? What is the meaning of a bond first? What is the meaning of bond? Bond in the sense, remember this one, bond in the sense it contains two electrons. Okay, so when bond breaks, what happens? These electrons are shared by both the atoms. Based on that bond cleavage, based on that sharing of electrons, this cleavage, this fission is of two types. Okay, this fission is of two types. What is that? Those two types? Homolytic fission and the heterolytic fission. Okay, so here how this homolytic and heterolytic we can say based on the cleavage of the bond. Okay, so here based on the cleavage of the bond, homolytic, heterolytic fission, what are these homolytic and heterolytic fission? Now we will see. So here, if bond breaks, when bond breaks, what happens? Bond is nothing but two electrons, right? So these two electrons are taken up by only one atom. So here in this image, you can understand here, here it is the two electrons are there. When bond cleavage takes place, both the electrons are shared equally. Both the electrons are shared equally. That is, equal sharing of the electrons takes place by the both the atoms. That is called as a homolytic fission. So here bond in the sense two electrons. This one electron is taken up by A atom, and this one more electron is taken up by the B atom. Okay, so here half electron, one electron is taking one atom and the another electron is taken up by the another atom. Equal sharing of the atom is taking place, so it is represented by the half-headed arrow. It is represented by the half-headed arrow. Arrow also should be like this, and here A will get one electron. Here A is taking one electron, right? So that's why A will get one electron and then B will get one more electron. Okay, so here these are called as free radicals. These are very reactive. These are called as free radicals. Okay, So equal sharing of electrons takes place, then it is called as a homolytic fission. Now come to the heterolytic fission. In this heterolytic fission, what happens here? Bond in the sense what? Bond in the sense two electrons. These two electrons are taken up by both the electrons. If both the electrons are taken up by only one atom. Okay, so if both the electrons are taken up by only one atom, that is A atom, electron means which charge? Electron means it is the negative charge. Here which atom is taking? A atom is taking the both the electrons. That's why A will get the negative charge. A, because electrons are taken up by A atom, so A will get the negative charge, and next B is not having any electron here, that's why here B will get the positive charge. Okay, so like this, if B atom takes both the electrons, like this, if B atom takes both the electrons, then B will get the negative charge and A will get the positive charge. Clear? Now here the point is, how can we identify which atom takes both the electrons? Okay, how can we identify which atom takes both the electrons? Means it depends on the electronegativity. The atom which is more electronegative, that electronegative atom, it takes or it attracts both the electrons from the bond. Clear? So here if A is more electronegative, A attracts both the electrons. If B is more electronegative, B will attract both the electrons. Clear? Like this, here A positive and negative charges we can see here in the heterolytic fission. So overall here from this homolytic fission and heterolytic fission, what you are understanding from this homolytic fission leads to the formation of a free radical, and heterolytic fission leads to the formation of ions. Those ions also either cation and anion. Clear? Now, these free radicals are very reactive species. They usually abstract an hydrogen atom from the hydrocarbon molecule. This is about the free radical. What is meant by a free radical? How it is formed. Clear? Now our topic is in the presence of free radical, polymerization reaction takes place. How it takes place? Now we will see the mechanism. So here the free radical addition polymerization proceeds through chain reaction mechanism. It consists of chain initiation, propagation and termination. These are the three steps taking place in this free radical polymerization. Okay, now here our topic is mechanism of free radical addition polymerization. Mechanism is nothing but we need to explain the series of steps of a chemical reaction. Clear? So now here now we'll see how our chemical reaction takes place in presence of a free radical. So to start a reaction or to start a chemical reaction, here we need the free radical first. We need free radical first. Then afterwards only by taking that free radical, we can do the chemical reaction. Clear? So to form a free radical, here mainly what are the compounds are used is azo compounds. Azo compounds means which contain the a double bond present between the two nitrogen atoms, and next peroxides. Peroxide bond means O2O linkage will be there, right? So here these two are the main commercially used initiators in free radical polymerization. So here how these free radicals are generated? Automatically generates means no. Here there will be a supply of heat or any photons of UV light. Okay, when they exposed to a light, then these compounds they undergo homolytic fission and forms the free radicals. Okay. So in this free radical polymerization reaction, now we'll see what are the steps. So what is the first step, students? First step is the chain initiation, right? So first we have to start the reaction, that is called as a chain initiation. To start a reaction, what we need? We need the free radicals, right? So here for radical generation, how these radicals are formed? They undergo homolytic fission. So how they undergo homolytic fission? When they expose exposed to the any heat or light, that is thermal decomposition, which is called as. So here thermal decomposition, thermal means heat. So it undergoes the thermal decomposition of peroxides or azo compounds. So the initial step is first they peroxides they undergo thermal decomposition and form the free radical. So here now we'll see how this free radical is generated. Means this is the peroxide. If O2O linkage is there, then it is called as a peroxide bond. Okay. So this peroxide here, bond cleavage or the homolytic fission takes place. Here it is RO. If 2 is not there here, that is alkyl. R means alkyl group, and then here like this it is formed. If 2 not there, it can be write like this, or directly 2 you can write like this here. Now here in this step, what you can understand here, here peroxide is there, it is undergoing homolytic fission in presence of light, and it leads to the formation of free radical. Clear? Now here when free radical is generated, then these free radicals are very reactive. That's why they react with the monomer what you have taken. Okay, so in the here first free radical should be generated, and then it will be reacted with the monomer. So what is our monomer here? Here a simple monomer has taken here, that is the ethylene. Okay, so ethylene means here it is the C double bond C. Now here whenever the double bond or the triple bond is there, then what happens? Either double bond. Okay, now we'll take the double bond. So here if double bond is there, what does it mean? One bond is the sigma bond, 100% it is the sigma bond, and next another bond is the pi bond. It is not even a bond, just it is a electron cloud. Okay, so here it is electron cloud of pi electron cloud, and this pi bond is a weak bond, so it can break easily. So here wherever the double bond is there we have to think that one bond will be broken, and then it gives electrons. Okay, keep in mind that concept and learn the answer now. So here double bond is there. This double bond here, it is containing one electron. So here by taking these two electrons, here it is plus. So here it is what is formed here, this free radical and this free radical. These two free radicals, they between these two it forms a bond here. Okay, it forms a bond here, and this another free radical is taken up by the carbon atom. Clear? Now here in this first step, what is happening? Monomer free radical. This is the monomer, and then free radical is there. No, so it is called as a monomer free radical. Clear? So what is meant by chain initiation? In the chain initiation, this monomer free radical is formed. Clear? So this monomer free radical, it reacts again with one more monomer. Okay, so it reacts with again one more monomer, that is called that step is called as a chain propagation. Okay, so in this chain propagation, it is characterized by, in this chain propagation, here it is radicalized monomer. Radicalized monomer is nothing but what here radical, it functions as an intermediate and in the propagation step, so a propagating radical. Okay, so here radicalized monomer means monomer free radical which is formed in the chain initiation. That monomer free radical, it reacts with the one more monomer molecule. Okay, so this is formed in the previous step. This is formed in the first step, that is chain initiation. Here it is reacting with the one more monomer. It is reacting with one more monomer. Again the same concept. Here the monomer means here double bond is there. In the double bond, one bond is the weak bond, that is the pi bond. It can break easily and gives electrons. So here it is it breaks easily, it gives electron here. Here already one free radical is there, and by the fission of this bond, one more electron, by taking these two electrons, it forms a bond here. Okay, so here bond is formed, and then this another free radical, here another free radical, it is taken up by the carbon. Okay, so like this, here one more free radical is there. If free radical is there, that is very reactive, it can undergo again the reaction, right? So like this, it will react with one more monomer, again free radical, like this, this process like this, it continues. That's why to terminate the reaction, we will add heat transfer agents. The third step is the chain termination. So in this chain termination, it takes place by radical combination, by two steps, that is radical combination and disproportionation. So in this, once we'll see the reaction, these propagating radicals, in this step propagating radicals becomes inactivated. Okay, so to terminate the reaction, we add heat transfer agents, so that it in this termination reaction takes place in two steps. One is called as radical combination and the second one is called as a disproportionation. So here what happens is, the two steps we will see in the termination. One is radical combination. Now you can understand from the word radical combination, that means in the previous step, that is in the chain propagation, whatever the product is formed, that we are taking now here, it is the product. Just if you see here, this is one propagating radical and this one propagating radical. The chain which is containing the free radical, the two chains, they collide with each other. Okay, the two chains, they collide with each other, and form, say, long chain. Then so that the reaction stops, or the chemical reaction will be terminated. Okay, so here if you see here, it is the free radical. At the place of free radicals, this plus will be removed. In this place, just write a bond here. If you see this one, radical combination step, this is called as a radical combination step. Here the two chains which is containing the free radicals, which are formed from the propagation step, they collide with each other and forms a polymer, that is the dead polymer. Here there is no free radical again at the end of the chain, either this side or this side, there is no free radical. So because the free radical is not there, again it cannot react with another monomer. Okay, so that like this, the chain termination reaction takes place. Now it leads to the formation of a dead polymer. Clear? So chain termination takes place from two steps. One is radical combination and the second one is disproportionation. Second one is the disproportionation reaction. In this disproportionation, what happens is, here in this step, many students are getting confusion. Just you understand the concept clearly. That is, hydrogen atom is transferred from one chain to another. In this disproportionation, just you remember only one point, that hydrogen atom transferred from one chain to another chain. That's it. Okay, so only remember this point, hydrogen atom transferred from one chain to another chain. So what is that one chain? What you got in the propagation step, only that step you have to take, that propagating radical you have to take. Okay, now we will see how this hydrogen transfer takes place. So this is one chain, polymer chain, plus this is another chain. Okay, this is another chain. What is our concept in the disproportionation of chain termination? Hydrogen atom transferred from one chain to another chain. So in this chain, the hydrogen atom which is present, which is attached to carbon, which is attached to the radical carbon. So here carbon is having the radical. I'll write here, carbon is having the radical, and this carbon is having hydrogen. Okay, and in this place I am writing only this place only, not the entire chain. And here it is, the here radical is there, and then this is the total chain. Okay, so here what happens, hydrogen atom from one chain, this hydrogen atom from one chain, it is attracted by the free radical. Okay, it is transferred from one chain to another chain. The here in the before slides we have discussed one point that the free radicals are very reactive and they abstract or they attract the hydrogen from hydrocarbon. Okay, so that point you can apply here, that is this hydrogen atom is attracted by this free radical and it attaches to this carbon. So here also bond is there, two electrons. With this electron hydrogen comes here. By using these two free radicals, it forms a bond here and it forms a bond here. Okay, and here one more radical is there, right? One more radical. By using this radical, it forms a bond here. Okay, so that is the concept here. Just if you see the reaction, you can understand this one. So here this hydrogen is attracted by the another chain. Hydrogen atom is transferred from one chain to another chain, and here the bond is there, one electron is there like this here only, this electron and this radical. By using these two, it forms the double bond here. So that is the double bond here. And here this hydrogen atom is attracted by the another polymer chain, that is this one. So because of this reaction, what are the byproducts are forming? One resulting in one saturated and one unsaturated chain. So what is meant by saturated? Saturated means if all single bonds are there, then it is called as a saturated compound. In the unsaturated means if any multiple bond, either double or triple bond is present in that compound, then it is called as an unsaturated compound. So because of this disproportionation reaction, just hydrogen atom transferred from one chain to another chain, that's it. So hydrogen atom transferred from one chain to another chain, then it leads to the formation of saturated and unsaturated compounds. Okay, so like this two byproducts, these two are formed. When you observe these two, there is no free radical again here, right? So our reaction is terminated. So that's why it is a chain termination reaction. Here again free radical is not there, so it cannot react with the monomer, or the reaction cannot continue. Okay, so like this the reaction will be terminated, leads to the formation of the dead polymer. Now we'll see what are the applications of this free radical polymerization. What is the use of this free radical polymerization, where it is used? We'll see the few applications. So it is lots of applications are there. It is essential technique for obtaining different polymers and material composites. This type of mechanism we used in synthesizing or in preparing the polystyrene and elastomers. And next one is it is used in synthesizing chemical surfactants. These are used in synthesizing or in the preparation of chemical surfactants. That means surface active reagents, surface active agents, or it reduces the surface tension. Those are called as chemical surfactants, which are used in the soaps. And the next one is these are used in the manufacturing of this type of free radical mechanism. It is used in the manufacturing of cardiovascular stent. We are very familiar with this stent. What is the meaning of stent? Means it is a small mesh tube. To prepare that small mesh tube, this free radical addition polymerization, this mechanism is followed. Okay, so this cardiovascular stents are used to treat narrowing the coronary arteries. That is in the cardiology, it is used in the coronary artery, means which that artery which supplies blood, oxygen rich blood to the heart. Next Today we'll conclude the topic. In this session, we have discussed about polymerization. What is meant by polymerization? We have discussed, and then types of polymerization. There are two types of polymerization we have discussed. That is addition and condensation polymerization. And the next one topic today that is very important long answer question, that is mechanism of free radical addition polymerization and its applications. Okay. And next, these are the few references for this topic. I hope this video is helpful to you. Thank you.